Okay, 7.3, triangle similarity. We are not only going to be looking at triangles, but this section is called triangle similarity. We are going to be working on polygons in general. Now, we need to decide, actually not decide, we need to discuss the difference between something that is congruent and something that is similar. We have done triangle congruency, correct? We did side, 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 we did side, angle, side, we did angle, angle, side, we did all that, didn't we? What does congruent mean? Equal, the same, exactly the same shape and the same side, correct? What does similar mean?
Almost kind of the same.
It's kind of the same. We did the Matchbox car, yes? Has the same angles, it's the same shape, but is it necessarily the same size?
Yes.
No. Every congruent object is similar as well. Okay? But similarity does not mean congruent. When things are similar, they have to have exactly the same angle measurements. Exactly the same angle measurements. They have to be the same shape, but the sides can be proportional. Remember we were starting to work on that yesterday? We were solving those proportions. We had the same ratio. So all the side lengths have to have the same ratio. We're going to be reviewing some words today like corresponding parts, and we're going to discuss how we can tell what is corresponding, what goes with what, right? And if you use the techniques that I'm showing you, you'll be fine. If you think you need to, in your head, pick up this shape, turn it around, and put it right on the other shape, you're not going to be fine, and it's going to take you 3 times longer to do the problems. Do you want to do that?
Yes.
Mason?
What?
Helpful comments? Okay, so the first rule for similarity, you have 3 rules on the front of your sheet for similarity. The first one is angle, angle, similarity. So when you look at the abbreviation, it has AA, which means what? Angle, angle. And this little tilde means, guess what? Similarity. When we did angle, angle, side before, we didn't put anything behind it, did we? Because they were congruent. Now we're saying similar, so when you write it, you need to put the little squiggly after. So, if 2 angles of one triangle are congruent, what's congruent mean? Same measure, right? To 2 angles of another triangle, then the triangles are similar. So the word of the week is not congruent anymore. It was like the word of the semester last semester was congruent, right? But it's not. Not now. It's similar. So let's look at my picture, guys. I have angle A is congruent to what? Angle D. How'd you know? It has one curve, right? One arc. Angle B is congruent to what? Angle E. So by this rule, if 2 angles are congruent, then these are similar triangles. Now I have a question for you. Is angle C congruent to angle F?
Don't know. Yes.
No.
Why, Ainsley?
Because if those 2 are the same and they all add up to 180.
They all add up to 180, yes? And if 2 are the same, does the third have to be as well? Yes. So, yes, they only call it angle-angle similarity, but could we call it angle-angle-angle similarity as well? Yes. And down at the bottom it says triangle ABC is, what does the symbol mean? Similar to triangle DEF. Now, we're going to talk about corresponding parts real quick before we get any further. When I look at the names of triangles and how I state their similarity, remember AB corresponds to what? DE. They're named correspondingly, right? So I have BC corresponds with what? EF. And AC corresponds to what? DF. If you just use their names to set up your ratios, like we do in a little bit, it will be much easier than trying to take the picture and turn it and flip it and put it on top of each other. Because our brain doesn't do that well, does it? Yeah, we all know what the transformation chapter was like, don't we? Do we want to go back there again? No. Okay. So now we have what? Side similarity. So if the corresponding, oh, I hate it that I forget that. If the corresponding sides of two triangles are proportional, then the triangles are what? Similar. You knew that? Good. So proportional means that all of them have the same ratio, right? Triangle 1 to triangle 2, triangle 2 to triangle 1. It doesn't matter which one you put on top to bottom unless you're talking scale factor. And right now we're not talking scale factor. Remember, scale factor was that shrink or enlarge, that dilation, right? So let's look down here. We have triangle ABC and DEF. So AB corresponds to what? DE. BC corresponds to EF. AC corresponds to DF. Do you see ABC, the triangle ABC in the numerator? Yes? Do you see triangle DEF in the denominator? Triangle 1, triangle 2. Do not mix them. Will it mess up your answer? Yes. For them to be similar, all of these ratios have to reduce down to the same. Make sense? Good on that? Okay. We're going to do all of these, but I might as well go through the rules, right? The last one is what?
Side angle side.
Side angle side. So side angle side. Two sides, and what's that angle? Where's it at? In the middle. Anybody remember what that was called?
Vertex.
Well, it is the vertex, but it's the what angle? If this side makes, not make that angle, what?
Triangle.
No, that may be, but that, nope. Included, remember talking about the included angle? The angle that the two sides make?
Yes.
Okay, so I have side angle side similarity, so SAS tilde. So, what do you think? If any angle of one triangle is congruent to an angle of a second triangle, and the sides that include the two angles are congruent, not congruent, how about proportional? Because congruent is not what we're working on, right? Proportional, then the triangles are similar. So again, let's look at our working picture of this. It tells me B and C are congruent, yes? So from this rule, if AB is proportional to DE and BC to EF, if they have the same ratios, then this triangle is similar, right? So that's what we're going to see. It's two sides. Oops, I moved that earlier so I wouldn't do that. Two sides and the included angle, the angle they make. Don't you feel like you're back doing the congruency again? Questions before we move on and use them? I will tell you, your problems are going to ask you, are these congruent? I'm going to tell you that, okay? These are the 3 reasons why they would be. That's it. Okay, so your reasons are going to be angle congruency, side congruency, or side congruency. Those are going to be your reasons. And you have to show your work that backs them up. You guys ready to move on? Okay, are A, B, C, and D, F, E similar? So what rule, what theorem is going to show me whether they're similar or not? You have 3 to choose from. Side, right? So the side rule said all of their ratios have to be equal. So we have to set up ratios, correct? So we'll just start. We'll put the okay, sorry. So we have equals. What I do is I make my proportions. I make my 3 ratios. So I have it start. You want to put the left triangle in the numerator or the denominator? Numerator? Good with that? Does it matter? No, it does not matter. So what I do is like, okay, I'm testing this triangle against this triangle. So I just write the sides down. 3, 4, 5. Because does it matter the first triangle what order they're in? Does it matter? No. Does it matter when I complete my ratio what order they're in? Yes. Okay, so 3 is AB. So what does AB correspond to in the other triangle? DE. So what is DE?
4.5.
So I put 4.5 underneath. Okay, and then I have 4, which is BC. EF, FE, which is 6. And 5 better correspond to what? Yep. So I did not have to guess. I didn't have to reflect or move or anything, did I? I just used their names. So now I need to reduce. I don't want to work with 4.5. How about you guys? You guys want to work with 4.5?
No.
Gross. Can I multiply the bottom by 10?
Yeah.
What do I have to do the top then?
Multiply by 10.
Yep. So I have 30 over 45, 4 over 6, and then what? What am I going to do with 5 over 7.5?
Times by 10.
Times by 10.
15 is 75.
Okay, I still have to reduce them, yes, but is it better on our brains? Yeah. Okay, what goes into 30 and 45? The biggest number you can think of? 15. I can do 5, but then I'd have to keep going, right? So 15 goes into 30? Twice? 15 goes into 45? 3? So everything better equal 2/3, correct? If it doesn't equal 2/3, my answer is no. So 4/6? 2/3? Okay, what about 50 and 75? 25, so I get what? 2/3. So is my answer yes or no?
Yes.
Yes. No. Semicolon by what? Side. Similarity. Don't forget your little... I'm sure it's called a tilde.
It is, I think.
I'm pretty sure it is.
I was trying to think of
I'm pretty sure it is a tilde. Make sense what we just did? Okay. Questions before we move on to the next example? Okay, so now I have, actually, how many triangles do I have in that picture?
3.
3. So let's look at which ones they actually want us to look at. So PQS, that's the big one, right?
Yeah.
Okay. And RQP. RQP is the little one? To the right. So I need this triangle right here, yeah? And I don't want to have to look at them together. So what I'm going to do is I'm going to make just a big triangle right here and name it SQP. Can't I do that? Yeah. Okay. So what are the side lengths? What's PQ? 18. And what is SQ? 27, because you have to add both 17 and 12, right? So now in this picture, do I even need this part of it?
No.
No, don't even need it. Okay, so let's see. Well, we've got 2 sides, correct? So which one of my rule talks about two sides?
Side angle, side.
Side, angle, side. Do we have the angle?
No. Yes.
Yeah, we do. Where?
The 90 degree angle.
Well, it's not 90. We don't know that. We have Q, don't we?
Yeah.
Q is in both of these triangles, isn't it? Isn't Q congruent to Q?
Yeah.
Yeah, it's that reflexive property. It doesn't have to tell me they're congruent because it's the same angle, isn't it? So we already know that Q is congruent to Q. So Q, angle Q equals angle Q. So we'll have to keep that in mind, right? And I put that at the bottom of my work. So we have to keep that in mind. So now we have to check if the other two are proportional. So which triangle do you want to put in the numerator? The large triangle or the little triangle? Little. Ooh, we got large or little. Does it matter?
No.
No. Not unless we're talking about scale factor, and that's not what we're going to talk about. Can we just do the little one since it's on top on mine?
Yeah.
Okay. So we're looking at this triangle first, right here. And it's important to know which one you're putting in the numerator, okay? So I personally always do the smallest to the largest, but do I have to put this 12 and 18? Could I put 18 and 12?
Yeah.
Yeah. Okay, so 12 is RQ. So what does RQ correspond to? PQ. And what's PQ in the big triangle? PQ. 18. We're in the big triangle. You have to remember which triangle you're in, correct?
Yeah.
It will not work if you don't. So 18
And 27.
was PQ. So PQ, not PQ, that is not PQ. PQ corresponds to
QS.
QS. Look at their positions in their name. So what's QS?
27.
27. So I have to reduce these now. What goes into 12 and 18?
6.
6. So you get 2/3. And as long as the other one is 2/3, these are similar, right? If it's not 2/3, 18 and 27.
Now it's
9, and then it's 2/3. So my sides are proportional, yes. I have the included angles, so is it similar? Yes. So it's yes.
Side angle, side. Similarity.
Side angle, side similarity. Just say similarity when you write it, because that's what it stands for. And there's no other words, guys. You showed me your work. Did you tell me why?
Yes.
Yes. As long as you're showing that work. That's why it's important to show that work. Questions, concerns? Okay. Pictures are just getting more complex, aren't they? I have 2 questions with this. You notice when I'm doing these, guys, I'm saying I'm looking at this triangle and I'm looking at this triangle. Like I'm specifically in my brain looking at these 2 triangles. Could I draw the 2 triangles separately on my paper when I'm doing my homework? Yes. You don't have to draw that picture. If I was redrawing the picture, I would not redraw that picture. How many triangles do I have there? 3. I have 3 and then I have a hexagon, right? No, pentagon. Okay, I have 3 and then I have a pentagon. So if I was looking at these 2 on the left, I would draw them separately on my piece of paper. If I was looking at the 2 on the sides, I would draw them separately on my paper. Does that make sense what I'm saying to do? Because you would get so hung up trying to make that picture, you'd forget what you were doing, wouldn't you? And we want to keep it simple, right? So we're looking at ADE, which is which one?
The little one on the
This one?
Yeah.
And we're looking at ABD, which is
big one.
the big one. So we're looking at these 2. So, well, we have, what are we going to use? Angle, angle similarity, side, side, side similarity, or side, angle, side similarity? Side, 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 why?
Because the sides, not the angles.
Yep, we have sides. We do have angles, yes. But do we have all the sides? Yes. We don't have the angles of both of these triangles, but we do have, like, on the 2 sides we have angles, but that's not what we're looking at. Okay, so we have side, 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 so I'm going to set it up for what? Side, side, side. And it doesn't matter which triangle we start with. I probably would start with ADE because it's on the left of what the question is, but does it matter if I start with that one? No. So if I go to ADE, I got what? 1.8, 1.8, and what? 2.4. So again, don't sit there and try to figure it out from the picture. Go to the names. Got it? Okay, so let's see. My first 1.8 I have is AE. So AE corresponds with what?
80.
80, which is
2.4.
2.4. And then my second 1.8 is ED,
DB.
which is DB.
2.4.
We're off to a good start so far, right? I'd hope all of you know that those are congruent or equal. And then the last I have is AD,
AB.
which is AB,
3.2.
3.2. Now, the last one we multiplied those two by 10 to make it easier. Here, everything has one decimal place, correct?
Yeah.
So can I just disregard the decimal?
Yeah.
Yeah. It's 18 over 24, 18 over 24, and 24 over 32. So 18 over 24, what does it reduce to?
9.
3/4.
3/4? Yeah, 6. And so obviously the next one would be 3/4, unless we were going to invent a new math procedure.
Wouldn't it be 2/3?
For what?
That would be 3/4.
It'd be 3/4.
Yeah.
Because 8,
Oh.
36 would be 12. Because you said 2/3, right?
Yeah.
That would be 12. Okay, so, and then 8 goes in here how many times? 3/4? So are those two triangles similar?
Mhm.
Yes, by what? Side, side, side. Similarity? Okay, so I'm going to erase some stuff here. Oh, actually, I could leave that. Okay, now I need ADE. That's still this far left one, isn't it?
Mm-hmm.
And that should be a C, shouldn't it? Isn't there a C on your paper?
Yeah.
Yep. Okay, BDC, which is here. I'm going to tell you BC, guys, is 1.4. I don't know why that's not there. BC is 1.4. Oh, actually, no. Wait. Never mind. Never mind. Nope. You can't say what it's going to be. Never mind. We're going to use what's on the picture. Okay, so this one, what are we going to use? Can't use side, side, side because we don't have what?
Side and the side.
Yep. We're going to have, what don't we have to use side, side, side?
On the third side.
Yeah, we don't have the third side. So we're going to have to use side, angle, side, aren't we? Okay. So let's see. Well, my angles, so so if I have this angle equaling this angle, right here, so that works. So angle D, well, actually I should write it the right way. What is it? Angle ADE, right? Is equal to angle BDC. So we know that, correct? So if that is going to be true, then AD over ED has to be equal to what? So AD is BD and DE is DC. So if this is going to work, that has to be, right? So what is AD? 2.4. What's ED? 1.8. And then, let's see, BC. Oh, BD, yes. Sorry.
2.4.
Sorry, I just said the wrong thing. And DC. 1.4. Well, we obviously know they are not going to be equal, correct? Because if the numerators are equal and the denominators are not, they cannot reduce. But we do need to reduce them. So 24 and 18,
6.
6. So I get 4/3. And then I get,
Use 2.
I'm going to use 2, so I get 12/7.
So is this equal? Nope. Nope. So I cross out the equal sign, remember? Just do that. And write nope.
Now, I don't have to say no because the sides are not proportional. I could, but did I show you that the sides were not proportional?
Yeah.
Yeah. So if I show my work, I can just write no and walk away.
We good so far? Okay, this is one picture, 3 questions. Okay.
It doesn't tell me that these two triangles are similar, do they?
Nope.
But we need to look at it. Let's see. Well, what do I know about...
They're vertical. Yep. I love that you used vertical. They're vertical, so we know they are congruent. Yes? We know that. Well, if I have LM is 1 and JL is 75 and LN is 1 and KL is 75, well, aren't those two ratios equal? That's 1 to 75 equals 1 to 75. So are these two triangles similar? Yeah.
Yes. So if they're similar, can I solve for them? I know that they have a ratio of what? 1/75. I know that. Yes?
Yep.
So I need to find MN. And are y'all good with calling that X?
Yeah.
Okay. So 1, X goes with 1, yes?
Yeah. Over 10.
And 10 corresponds, JK corresponds to MN, doesn't it? Yeah? And JK is 10. And have we not been working on proportions beginning of this week? So I multiply by 10. So X equals 10 over 75. So X equals what?
7.5.
Let's just reduce it to 2/15. Yeah? Okay. We're just going to reduce them for now. Unless it says specifically to give a decimal, we're going to leave it like that for now. Okay, so X is 2/15 with this picture. That's pretty easy, right? That's why I've been working on proportions all week. Next question says, what happens if I change JL to 150? Well, that would just make this 75 right here 150, wouldn't it?
Yeah.
So I would get K equals 10 over 150, which would be what? 1/15? Because the zeros would just reduce. So 1/15. So what happened now? What happened? I went from 2/15 to 1/15. How did those two compare?
This is double.
What?
So it's double. The 75. 150 is double. So.
Yeah. Well, 150, I doubled that side, but I didn't double MN. What happened to it? It went from 2/15 to 1/15. It's half of it, isn't it? So my side got longer, but those ends got what?
Smaller.
It got smaller. So I didn't change the KL. The KL is still 10, isn't it?
Yeah.
But as I extended that JL out, it made MN half. It's half, isn't it?
Yeah.
Half of what it was. That's interesting, right? And we're going to talk about how and why in a second. Well, the next one says we're going to do what? Make JK right here 20. So we're going to put this back to 50. So I'm going to rewrite the original problem since I'm further away.
Back to 75.
So I have 1/75 over X over what? 20? So that would be X equals 20 over 75, which is what? 4/15. Now wait a second. What happened to MN now? It doubled.
It's twice as large, isn't it? Okay.
Now, let's talk about why it happened. So 10 corresponds with the MN, doesn't it? Like 10 directly corresponds with MN. So if I double 10, does it make sense that I would double MN? And is that what happened? Yeah. But the JL does not directly correspond, does it? No. It made my ratio smaller, didn't it? It made my ratio smaller, and so since that happened, then would it make sense to make my side smaller? Yeah. So you'll be looking at scale factor as we go. We'll just kind of intermittently put it in there and discuss it. But it's going to change, so don't make assumptions. Do the math. The math wasn't hard to do, was it? No.
So that is it for us today.